session of digital transformation education workshop. And now we start the last our session, and the first speaker is Natalia Nazukova and Ina Lunina, and his report School Digitalization Indicators in Educational Equity Analysis. Are you ready?
Yes, thank you, Tatiana.
Please share your screen. Okay, we see your screen. Please start.
Hello, dear organizers and participants. Taking this opportunity, I want to thank the organizers for a high-quality organization and the participants for excellent, very interesting reports. Our study is dedicated to the school digitalization indicators in educational equity analysis. And the report is structured as follows. First, I'll introduce and explain the relevance of the research. Then I'll turn to the framework, data, some descriptive statistics. Then we'll turn to the methodology of the research. And at last, we'll discuss some results and possible policy implications. It's important to analyze not only the information and telecommunication in education, but also the role of ITC in a set of other educational indicators. Specifically, we are talking about educational equity indicators. The strategic relevance of this study and this type of studies is connected to the need for a strategy for education system that combines educational opportunities and digitalization. Understanding the relevance of the issue, national and supranational governments incorporated this issue into their strategic documents. For instance, European Commission has issued its Digital Education Action Plan for the period 2021-2027, which clearly states that creation of education and training systems adapted to the development of digital era should be carried out with the aim of achieving more effective, sustainable, equitable development of digital education. In Ukraine, we have conducted the concept of development of the digital economy and society of Ukraine for 2018-2020. And it clarified the existence of an issue, of a problem. For instance, it stated that there are inequalities in access to opportunities in educational fields, and that they exist and exacerbate as a result of incomplete, insufficient access to telecommunication, digital technologies, and computers. Next, to solve this problem, this issue, we have a Ukrainian state strategy for regional development until 2027, which has set several digital KPIs, key performance indicators. For instance, that the percentage of schools using fixed broadband internet access must reach 100%, and that coverage of population on all territories with 4G mobile networks must reach 90%. So what concrete indicators, taking into account all the above, did we take into our analysis? We have grouped them onto three groups: physical accessibility indicators, digital accessibility, and shadow education accessibility. In physical accessibility group, we have analyzed two indicators, X1, which is the number of students per teacher, and X2, which is the number of students per general secondary education institution. In digital accessibility group, we have analyzed two levels of indicators. At household level, X3, which is the number of households out of 100 provided with fixed access to the internet, and at school level, X4, which is the number of computers in school connected to the internet, and X5, which is the number of schools with classrooms with interactive whiteboards. Taking into account the results of the studies on the role of parents' ability to finance tutoring for their children on the educational outcomes, we also incorporate the factor of shadow education or tutoring accessibility into our analysis. Specifically, we measure it as the number of search queries in the Google search engine for the keyword tutor carried out in a specific region. We have obtained this data from a set of sources, from the State Statistics Service of Ukraine and their annual reports on general secondary education in Ukraine, from the National Commission for the State's Regulation of Electronic Communications, Radio Frequency Spectrum and Provision of Postal Services and their annual reports, from which we have gathered information on the number of households with internet. From the Ministry of Education and Science and Institute of Educational Analytics and their informational bulletins on the D4 statistical form on the accommodation of general secondary educational institutions with ICT, and from Google Trends analytical tool on X6 indicator. So the data we've obtained include 91 observations for each of 6 chosen indicators, X1, X2, and so on, till X6. This data include 23 regions of Ukraine and the period from 2019 to 2022. However, this data has different units of measurement. That is why we've conducted its standardization on the basis of well-known statistical instrument, and we've obtained standardized data indicators Y1, Y2 until Y6. Now we can conduct the factor analysis to find out which of the chosen indicators have the strongest impact on educational equity. And to do that, we've chosen the principal component method. One of the advantages of this method is that it shows not only the power of the impact of concrete factors, but also shows the direction of the impact. A linear model and corresponding formula is shown on the slide. The intermediate result of the application of this method is obtaining of uncorrelated factors, principal components, F1, F2, and so on till F6. The amount of those principal components equals to the amount of initial data. Okay. But the final aim of this analysis is not the principal components. We have to find the Y-back quotes, the normalized values of each of the indicators we have chosen. To do that, we need to know the weighting coefficients of each of the principal components in each of the indicator and the values of each of the principal components in total variance in all the set of the observations. In our lab software, we've conducted several inbuilt functions, and we've obtained the weighting coefficients, 6 of each of principal components in each of the 6 indicators. And we've obtained the statistical description of the data. As you can see, first 4 values of the contribution of the principal components captures 96% of the total variance of a set of observations. That is why we don't have to analyze all of them. We can look only at the first 4 rows of the weighting coefficients of the principal components in each indicator. And now we can calculate Y-back quotes. So the normalized values of the indicators of general secondary educational equity in Ukraine are as follows. The provision of households with fixed access to the internet, as well as the number of computers in a general secondary educational institution connected to the internet, plays the greatest role, have the greatest impact. While Y backward 5, the number of interactive whiteboards appear to be much slower, much weaker. And what is interesting is that Y backward 6, which is intensity of tutoring, appears to be not very weak, but also negative. What concrete practical conclusions can we make from these results? As I have already mentioned, the principal component method allows us to see not only the power of the impact, but also the direction of this impact. As you can see from the graph, each of the groups of indicators we have grouped at the very beginning act differently from other groups, which is not surprisingly and proves that our grouping was conducted well. What is interesting is that X6 indicator, that is the intensity of tutoring, appear to be almost opposite to X1 and X2 indicators, which are the physical accessibility indicators. And what practical applications from these results? First of all, providing households with fixed access to the internet, as well as connecting schools to the internet, can sufficiently improve the equity of general secondary education in Ukraine. And second is that providing a sufficient number of school teachers will reduce the burden on families with teachers, because a decrease in the number of students per teacher will reduce parents' spending on tutoring. The results of this study are consistent with the KPIs we have mentioned from the State Strategy for Regional Development until 2027. And the intuitive perspective for the research is that we should incorporate teachers' quality, digital skills of teachers to the UNITE model we have presented, because this factor will, as we expect, play a great role in improving educational equity. Just not to take much time, I'll just conclude that this study adds a little bit to the understanding that in a speedy digitalizing world, educational digitalization indicators appear to be dominant in comparison with traditional physical accessibility indicators, as well as in comparison with parents' involvement in educational process. And I thank you for your attention.
Thank you. Maybe have anyone some questions? Okay, I have a question. The first question. You mentioned key performance indicators of the Ukrainian state strategy for regional development until 2027. For instance, that the percentage of schools using fixed broadband internet access must reach 100%, and that the coverage of all population with 4G mobile networks must reach 90%. Have those KPIs been reached, and what does that mean for the digital education equity? Thank you.
Thank you, Tatiana, for the question. Well, those KPIs are actually well designed in view of the importance of achieving educational equity in era of digitalization. However, those KPIs, well, first of all, they are almost reached, not fully. We have 97% of schools with internet, not 100. And we have 29.8 million people with 4G mobile networks in 2023. Unfortunately, I can't say what percentage it is because we don't have reliable statistics. But we may conclude that those KPIs are almost reached, not fully. However, those KPIs cover only the software, the so-called software side of the problem. We also have the hardware side of the problem. As if I remember well, then 8 to 11 children per one computer we have nowadays at schools. And practically, average amount of pupil per one computer is 2 and more in Ukraine. So the situation didn't change since the last 20 years, I guess. This is not surprisingly, because the average, the amount of state financing of education didn't improve sufficiently since then. The highest level of public financing of education was in 2009. It was about 8% of GDP. Nowadays, we have about 6% of GDP, and it is not enough to improve situation in hardware side of the problem. So what we can do is to reprioritize the sources we have in favor of information and telecommunication in school.
Okay, thank you. And we have one more question in the chat from Olga Pinchuk. You say that teachers' digital competence can enrich a set of factors of educational equity in Ukraine. Is this a future research perspective? And do you have other research perspectives connected to this study? Thank you.
A very good question, thank you. Well, we have had some expectations from the Ukrainian Center of Assessment of the Quality of Education, which has conducted research and has reported on the results of testing of knowledge and skills of teaching staff in 2023. But unfortunately, we didn't see the results for informatics teachers. We had only mathematics, primary schoolers, and Ukrainian language. So we cannot, unfortunately, incorporate the data into our UNITE model, but we still expect that maybe in future this tendency will change and they'll include those important stuff into their assessments. And another possible development of the study, we see it in the usage of the obtained normalized indicators to build an integral educational equity index that would be appropriate for dynamic analysis of educational equity in Ukraine. The normalized indicators are the characteristic values of the absolute measurements of the initial data.
Okay, thank you. Maybe someone want to ask the questions more? Okay, we know her question. Thank you very much for your interesting graph. And now we come to the next our presentation and our speaker, that developing and validating and integrated three-tier multiply choice test for smartphone-based experiments in physics. And now our speaker is Frank Angelo Pacala. Please.
Good afternoon to everyone. I think it's afternoon already there in Ukraine. Thank you, Ms. Tetiana, for hosting this event for the DigiTrans conference. Ms. Tetiana, I think I sent a video presentation to the committee. Can you?
Okay, yes, I can turn your video. 1 second, please.
Thank you.
1 second. Natalia, please don't share your screen. Natalia Nazukova, please off your presentation. Oh, okay. Yes, 1 second. Okay, I start the presentation from Frank.
Pleasant morning to all the participants, the committee for the 19th International Conference on ICT in education, research, and industrial applications, especially to the working group for the third workshop on digital transformation of education. I would like to say my thanks. I'm very grateful for inviting me for this occasion. I'm Mr. Frank Angelo A. Pacala. I'm a PhD candidate of the University of San Carlos in Cebu City, Philippines. My study will talk about a test instrument entitled Developing and Validating an Integrated Three-Tier Multiple Choice Test for Smartphone-Based Experiments in Physics. So a one-tier test will look like this one. On the above, you have a stem. We call this one a stem. And you have some destructors, or often we call this one as the options. Now, a two-tier test will look like this one, by which you have another section of the question by which somehow the student or anybody answering the test will state the reasoning of his answer coming from the tier number 1. So this is an example of a two-tier test. Now, according to He et al., they argued that the two-tier tests offer a more comprehensive assessment of understanding, proving the factual knowledge and thorough process and reasoning behind participants' responses, and that is right. Because here the student will support an evidence why her or his answer in the tier number 1. Now, a three-tier test would look like this. Now, on this one is the first tier, second tier, and below is a third tier. Now, in this one, an example is, how sure are you in your answer and reasoning? Very sure, sure, I only guessed. Here, we will find out the confidence level of the students. How confident are they in answering the test? The third tier prompts them to assess their confidence or certainty in the response. According to Lively, he emphasized that this feature provides valuable insight into the responses, reliability, and accuracy, metacognitive awareness, and self-assessment skill of the students. The teachers will find out if the student is not yet confident in moving into the next lesson, or how much confidence the student gain in answering the test if the same question or the same format of question will be given in the summative assessment. Now, different studies have studied smartphone-based experiment. Remember, this study is making a validated and reliable instrument on holistically determining the efficacy of smartphone-based experiments. Now, I have cited here 5 studies like Kai et al. 2021. The constructs of these Earth studies are on cognitive loads and self-efficacy, which is a one-tier test. Now, Hawkbird et al. Also measured the student's conceptual understanding using a one-tier test. Nico and Economides in 2018 also measured conceptual understanding of students using a one-tier test. Tironi et al., critical thinking, their constructs, and it's a one-tier test. He et al., which is a diagnostic test, and a two-tier test, diagnostic test in smartphone-based experiment. Now, in coming up and summing up with all of this literature, it is found out that a holistic instrument that measures both the conceptual understanding and science process skill is needed to measure students' overall performance during a smartphone-based physics experiments. Now, why I insist that there must be an integrated and holistic instrument combining the conceptual understanding and science process skills? It's because these two constructs are made of the same ladder, which I will discuss a little bit later. Now, these are the research aim. This research aims to create a well-designed, reliable, and validated instrument to to measure the interventions impact, which is now the smartphone-based experiment, on students' conceptual understanding and science prize skill of various physics topics. These are the research questions. What is the instrument's point estimate of Cronbach's alpha? How many factors this instrument can measure? And what is the level of content validity of the instruments? So, as I said, if you will take a look at the construct of conceptual understanding, measuring it using the Bloom's level of taxonomy, so it starts from remembering to evaluating. And for the SPS or the science prize scale, it is observing, predicting, experimenting, communicating, and controlling variable. Now, my contention is that remembering and observing or predicting even will use the same skill. Okay, you will use the same skill. Understanding, applying is in the experimenting, because in experimenting, you need to understand the context of the text. You need to apply it. And the same thing, you cannot communicate if you did not analyze, apply, and understand. And obviously, you cannot control the variable if you do not properly evaluate the set of experiment that is undergoing. Also, sorting, classifying, making inference, measuring, although measuring is somehow in the experimenting, and obviously graphing is applying what you have learned in that experiment, making inference. Now, what I'm saying here is that there is an overlapping constructs between the science prize skills and conceptual understanding. And so an integrated, making a reliable and validated instrument to measure holistic development of students in the realm of smartphone-based experiment must be undertaken. So the instrument was developed using the principles of assessment design of the Trends in International Mathematics and Science Study, the TIMSS, and the Cambridge Assessment International Education, or the CIE. We know that a lot of countries have lagged behind in terms of science education. And the reason for that is there is a misalignment between what are the tests given inside the classroom and the tests that the students will be answering during the TIMSS exam. And so there must be a coherence and alignment of what we're doing in the classroom and what the TIMSS tests are giving. So this test covers the physics topics of measuring acceleration due to gravity, magnetic fields, Doppler effect, momentum, and collision. These topics are commonly taken by students aged 16 to 18 under the Advanced Subsidiary AS level of Cambridge and A-level programs of Cambridge. So this is the example test that I have made. So the ITTM-CT, or the integrated three-tier multiple choice test, which contain tier 1, tier 2, and tier 3 options or tests parts. So to score this test, so in 2019, I think I made a assessment scoring for this. So with connection to alternative conception, because in a three-tier test, especially in tier 2, you will find a lot of misconceptions that the students have. And especially if they are confident with their misconception, it must be corrected. And so this is a very good instrument to measure student understanding in a three-tier test. So start with the complete understanding with 5 points and no understanding with 1 point. So the instrument was sent to a group of teachers for the pilot testing, 8 teachers. So they answered the test and their comments was amassed. And these comments were also inserted for instrument revision. Now, the instrument, after the comments coming from the 8 teachers, the instrument was revised and the comments and suggestion were incorporated in the instrument revision. Now, during the final administration, 30 teachers were answered the test, and 10 experts also validated the test for content validity. So the final administration encompass a validity for 10 experts, and then 30 teachers for reliability. So to analyze the results and the data of the results, so this JASP software was used. JASP software is a free software that we can download and use from the internet. Just search JASP in Google. So for the reliability, so the 37 item test was the result of the 37 test was inputted in the JASP software, and the total point estimate, the overall point estimate is 0.766, by which when we remove items 8, 11, 18, 28, 30, and 36, it will reach to 0.766. And in a instrument development, a good instrument must have at least 0.600 to be considered a good instrument. So since this is above 0.600, we can consider this instrument to be good and reliable instrument. So for content validity, as I mentioned already, 10 experts who are coming from a group of experts in instrumentation development validated the instrument. So they validated the instrument by relevance, clarity, simplicity, and ambiguity. So they measured the CVI, or the content validity index, for the instrument, by which if the appraisers appraise the instrument with 3 and 4, then it can be considered as relevant, it's clear, it's simple, and it's not ambiguous. So in table 7 here is an example of how the CIV was calculated. For example, in item number 1, so 9 experts said it is relevant. So 9 divided by 10 is 0.90, and the interpretation is appropriate. So if it is 0.60 or 0.50 below, it should be eliminated. So here, item 7 is eliminated. So for the construct validity, when the data for the CIV is there, now the construct validity of the instrument must pass 2 tests in order for the EFA to happen. So the first test is the Kaiser-Meyer-Olken KMO test and the Barley-Spherity test. So the KMO value was 0.500, so it is at the ceilings, because to pass, the KMO must be 0.500 and above. And the Barley-Spherity test yielded a chi-square test with a p-value of less than 0.001, which is lower than significance value of 0.05. So this means that the instrument passed both the KMO test and the Barley-Spherity test. So now the assumptions for the exploratory factor analysis are met. So the EFA will now commence. Now, inputting the data again in the JASP, so it revealed this graph. In figure 1 is the script plot of BFA, which shows components derived from the JASP software. So it identified, if you will see on the graph, the 10 components have an eigenvalue of greater than 1. So the 10 identified components account for 87.6% of the total variance. So this statement suggests that the integrated assessment tool evaluates a primary element of aspect known as the ability, according to Hambleton, Swaminathan, and Rogers. So in this study, that ability is called SPS and conceptual understanding. So the integrated, so it means that the tests are intact, 87.6% of the total variance. So here in table 1, I present to you the factor loadings per item. So high loadings on the same principal component, meaning that they measure the same construct. For example, item 6, item 25, item 26, item 7, item 32 have strong factor loadings on PC1. So later we need here we need to identify what construct is PC1. And then PC2 items 12, 37, 27, 33 and so on and so forth. So there are values here that are not given. It's because that their eigenvalue are low, so they are not shown here. So eigenvalues that are shown here are greater than 0.5. So to identify and group the items, so like if we will read through the question, as I read through the questions and the experts also, which I submitted to the experts. For example, PC1 accounts for remembering questions. PC5 accounts for evaluating questions. So PC6 account for items 14, 17, 31 are remembering questions. So that means here that many questions are coming from remembering construct. And for evaluating, there are 5 questions, which is the highest level of Bloom's taxonomy. So that means the instrument can measure questions that are low level, which is remembering questions, going to the very high level, understanding, applying, analyzing, and evaluating. So that's how the items now are grouped and identified. So conclusion, based on the instrument's analysis result, the integrated 3-tier multiple choice test this paper developed is now considered valid and reliable. So the instrument has good internal consistency based on Cronbach's alpha. The revised and retained items were relevant, clear, simple, and their meanings were clear. So the instrument passed both the KMO and Barley's sphericity test for EFA, and the EFA results found that the instrument measured the teacher's combined conceptual understanding and science press skill. So this paper recommends evaluating the levels of teachers and students' SPS and conceptual understanding using a 3-tier test to determine the alternative conceptions that teachers and students have and device intervention. So finally, we can say that the instrument now can measure whatever misconception or alternative conception or common understanding or science practice skill the students and teachers have during a experiment by utilizing a smartphone. Experiments utilizing a smartphone. So this means also that the instrument can be a it can measure mass production of students' understanding and science skills. It can be used for a simple group or a large number of students, and then the results will be more reliable, more holistic, and more valid. So before I end the talk, I would like to share this quote coming from Malcolm X. So education is the passport to the future, for tomorrow belongs to those who prepare for it today. And those who prepare the lunch of our students for tomorrow is us. So let's prepare the students. Let's make reliable, valid instruments that we use inside the classroom. So thank you for your attention. And again, congratulations to the committee, to the participants, to the viewers and listeners of this conference. So God bless us all. Thank you.
Thank you. I have a questions, please. What are the main advantages and challenges of using 3-tiered multiple choice tests to assess students' knowledge of smartphone-based physical experiments?
So obviously, if a 1-tier test with a STEM and then 4 distractors can take time, so obviously since there are 3 tiers, so obviously it will take more time. However, like it may take around more than 1 hour for a 40 item test. However, the contention is that even though it is time consuming, it means that we can measure the alternative conceptions of the students and their common misunderstanding of a particular topic, which is very important for us teachers. We must know their misconception because we must provide feedback to the students. And that is what education is, correcting what is wrong. Because learning is an experience. Students must experience wrong and we must correct it as teachers. Because getting wrong is common for humanity, but correcting it is a must for us teachers so that the students will not get wrong in the next coming test or preparation for life.
Thank you. Questions, please.
Thanks. I have a question too.
Please.
So, how can the result of this pedagogical experiment affect the future use of digital technologies in teaching physics?
So this three-tier test, we can make this three-tier test in a we can digitize this test in a website. So as to the effect, like it will only measure the combined integrated conceptual understanding and science process skills of the students. So the effect will be, instead of having two tests, like we wanted to know how much they learn in the classroom and how much is their science process skills. So at this experiment can measure them both. So instead of having two tests, this one we only have one test that can measure both constructs. So the effect is that we will we lessen the time for testing the student, because sometimes we test the students too much, especially here in Asia, that we test students too much. So now the testing will be limited now to one instrument in terms of this smartphone-based physics experiments in physics.
Thank you.
Okay, thank you. Other questions? No. Okay, thank you. And go to the final report.
Thank you.
Immersive cloud-based education environment of the university principles of decision. Tatiana, show please.
Okay, do you see my presentation?
I see your presentation. Start, please.
Okay, thank you. Hello, dear visitors. Let me present you the main result of the study, Immersive Cloud-Based Educational Environment of the University Principle of Design. The author is Sergey Semerikov, Tatiana Vakaluk, Irina Minty, Vita Hamanyuk, Olga Bondarenko, Pavlo Nichipurenko, Svetlana Shokaluk, and Natalia Moiseyenko. Okay. The development of digital technologies, particularly cloud computing and immersive technologies like virtual and augmented reality, is transforming various sectors, including education. Universities are increasingly adopting these technologies to modernize their educational environment and provide more engaging, interactive, and personalized learning experience to students. However, designing effective immersive cloud-based educational environment is a complex task that requires careful consideration of pedagogical, technological, and organizational factors. The presentation based on our research paper aims to provide a theoretical and methodological foundation for the design and implementation of immersive cloud-based educational environment in university. The rapid advancement of cloud computing has made powerful computing resources and services widely accessibility and affordable for educational institutions. At the same time, immersive technologies like virtual reality and augmented reality have matured and become more accessibility with a wide range of educational applications. The combination of cloud technologies and immersive technologies open up new possibility for creating innovative educational environment that can enhance learning outcomes and student engagement. However, there is a lack of comprehensive theoretical and methodological frameworks to guide the design and implementation of such environment in the university, especially in the Ukrainian context. Our research aims to address this gap by studying the state of the art, analyzing existing experience, and proposing a set of principles and models for designing immersive cloud-based educational environment. The main research questions of our study are: what is the current state of trends in the use of cloud and immersive technologies in university education in Ukraine and abroad? What are the key components and characteristics of an immersive cloud-based educational environment? What principles should guide the design of such environment to ensure their pedagogical effectiveness, technological feasibility, and economic efficiency? How can the use of immersive technologies in a cloud-based environment contribute to the development of students' digital competence and professional skills? To answer these questions, we set the following objectives: to analyze the specific literature and current practice related to the use of cloud and immersive technologies in higher education, to define the concept of and main components of an immersive cloud-based educational environment, to identify and contain the principle of designing such environment, to develop a model of using immersive technologies for developing students' digital competence, provide recommendations for the selection of cloud services and immersive tools for building education environments. To achieve the objectives of our study, we used a combination of theoretical and empirical research methods. Theoretical analysis and generalization of scientific sources of the problem, designing innovative educational environment. We provide literature on the use of cloud technologies and immersive technologies in education, with the focus on higher education and the university context. Second, is the study of and analysis of experience of using cloud and immersive technologies in educational activities of university. We analyzed case studies, reports, and publications describing the implementation of cloud-based learning environment and immersive learning projects in different countries. Third, there is a systematization and classification of the obtained factual data. We categorize the collection data according to different criteria, such as the types of technologies used, the pedagogical approach employed, and the such areas addressed. And the next is modeling the structure and principle of designs and immersive cloud-based educational environment. Based on the theoretical analysis and the empirical data, we developed a conceptual model of immersive cloud-based educational environment and identified the key principles of its design. The use of these complementary methods allows us to obtain a comprehensive understanding of the research problem and to develop theoretically grounded and practically relevant solutions. One of the key outcomes of our research is the conceptualization of an immersive cloud-based educational environment. We define it as follows. An immersive cloud-based educational environment is an innovative technological and pedagogical system that integrates cloud platforms and services, immersive technologies, virtual and augmented reality, and e-learning resources, and provides for the active interaction of learning subjects with virtual objects. The definition highlights several important aspects. Our immersive cloud-based educational environment is a complex system that combines technological components, cloud service, immersive tools, and pedagogical components, learning resources, and teaching methods. It leverages the power of cloud computing to provide a scalable, reliable, and as infrastructure for hosting educational services and resources. It uses immersive technologies to create interactive, engaging learning experience that all students to manipulate the explorer virtual objects and environments. It involves active participants and interactions of learning with the virtual content rather than passive consumption of information. It aims to provide a holistic integrating environment that supports various educational activity and purpose. Thus, the concept of immersive cloud-based educational environment represents a new paradigm in the design of university learning environment, one that fully harnessed the potential of digital technologies to transform and change education. Let's see the components of immersive cloud-based educational environment. Building upon the conceptual definition, we can identify the main components that constitute an immersive cloud-based educational environment. First is cloud platforms and service form the technological foundation of immersive cloud-based educational environment. This includes learning management system for organizing the educational process, delivering content, tracking student progress, cloud storage and file sharing services for storing and distributing educational resources, communication and collaboration tools for enabling synchronous and asynchronous interaction between learner and teachers, data analytics services for collection and analyzing learning data to personalize the instruction and improve educational outcomes. The next is immersive technologies are used to create interactive and engaging learning experience. The main type are virtual reality VR, which immerses the user in a fully artificial digital environment, augmented reality, which overlays digital content on top of the real-world environment, and mixed reality with ensures virtual objects to the real world and allows interaction between them. And the next is learning resources as the digital content and tools used for teaching and learning within the immersive cloud-based educational environment. This includes multimedia learning materials, text, image, video, audio, interactive simulation, virtual labs, educational games, immersive VR application for exploring concept and practical skills, digital assessment tools. The next is a method of using cloud and immersive technologies refers to the pedagogical approach, the techniques for effectively integrating these technologies into the educational process. And the last is community of education process participants, students, teachers, social administrators who interact and collaborate within in the immersive cloud-based educational environment. The integration and interoperation of these components creates a holistic technology and change learning environment that support active, personalized, and practice-oriented education. So let's describe principles of designing an immersive cloud-based educational environment. Based on our analysis of exciting research and practice, we have identified a set of key principles that should guide the design of immersive cloud-based educational environment in university. The first group of principles focus on the openness and accessibility of the environment. So it's the architecture of environment should be a modular, extensibility, and interoperable, allowing for the integration of new tools and services. The environment should support open standards and interfaces for data exchange and content sharing. It should provide a mechanism for user authentication and access control while enabling single sign-on across different services. The user interface should be intuitive, user-friendly, and accessibility to learners with special needs. The second group of principles relates to personalization and adaptability. The environment should allow for personalization of learning paths, content and assessment based on learners' needs, preferences, and performance. Should use learning analytics and AI techniques to provide target recommendation and intervention. The immersive content should be adapted to different learning styles and should support multiple modes of interaction. The third group focuses on innovative and practical orientation of the techniques used. The environment should leverage cutting-edge technologies and tools that have problem educational value and are relevant to the needs of the industry and society. It should support a project-based, problem-based, and experiential learning approach that develop practical skills and competence. The immersive technology should be used not for their own sake, but to enable learning activities that would be impossible or less effective with traditional means. Principle of design and immersive cloud-based educational environment. Second part is the first group of principle enhancing the need for integration of traditional and cloud-based learning tools. The environment should not aim to replace traditional teaching methods and tools, but rather to complement and enhance them. It should allow for a smooth integration of face-to-face and online learning activities, supporting blended learning models. The use of immersive technology should be pedagogically justified and aligned with the learning objectives and content of the course. In addition to these four main groups, we have identified several other important principles. Purposefulness and developmental orientation, consistency and integrity, collaboration and interactivity, security and privacy, cost effectiveness. These principles form a comprehensive framework for designing immersive cloud-based educational environment that are pedagogically sound, technologically advanced, and user-centered. They can guide the decision-making process in the design of and implementation of such environment in higher education institutions. So, to inform our research, we have analyzed the current state of adopting and use of cloud technologies in university with a focus on the Ukrainian context. We have found the Ukrainian universities actively implementing cloud technologies to support various aspects of their educational, scientific, and administrative activities. Some notable examples include Kryvyi Rih National University has implemented a cloud-based learning management system based on Moodle, integrated with Microsoft Office 365 and Google Apps for Education. This has enabled personalized learning paths for students and effective monitoring of their progress and achievement. Second, Zhytomyr Polytechnic State University cloud platform and web-based development tools for practical training of future IT specialists. For instance, in the database course, students use cloud-based database management system like Google Cloud SQL and Microsoft Azure SQL database to solve real problems. In the context of the COVID-19 pandemic, many universities have rapidly transitioned to distance learning using cloud platforms. This has required the development of guidelines for selecting and using cloud services for online lectures, assessment, student support, and lockdown conditions. This example demonstrates the benefits of cloud technologies for enhancing accessibility, flexibility, and effectiveness of university education. However, they also highlight the need for methodological support and teacher training to ensure the pedagogically sound use of this technology. In the next slide, we will look at some international experiments with the implementation of immersive learning environment. Okay, compared to Ukrainian university, foreign institutions have made significant progress in designing and implementing immersive educational environment using virtual and augmented reality technologies. Some notable trends and examples include: first, many leading universities such as Harvard, Mead, Stanford, actively experimenting with immersive technology, technologies, creating with virtual labs, simulation, game world for learning. We see VR and AR as important tools for improving educational quality providing practical skills and meeting the demands of the digital society. There are several large-scale international projects aimed at creating shared immersive learning spaces. For example, the Immersive Learning Space platform allowed students from different universities to collaborate in a single virtual environment, to work on joint projects, participate in professional simulation, conduct research. The design of immersive learning environment often involves the integration of multi-platforms and tools such as learning management system, VR/AR application, 3D modeling tools, game engines. Prokopenko, please turn your microphone. The next is a pedagogical approach used in immersive environment, enhancing active learning, personalization, gamification, development of key competencies through realistic virtual experience. This international experience provides insight for Ukrainian universities seeking for implement immersive cloud-based learning environment. However, the adopting needs to take into account the specific context need to resource of each institution. Okay, the conclusion and future work. In this presentation, we have discussed the result of our research on the design of immersive cloud-based educational environment in university. The key takeaways are: the first, the combination of cloud technologies and immersive technologies open up new opportunities for creative, innovative, engaging, and effective learning environment. The next, the concept of an immersive cloud-based educational environment represents a new paradigm in university education, one that integrates technological and pedagogical innovation. The design of this environment should be guided by principles of openness, personalization, innovation, integration, purposefulness, collaboration, security, and cost effectiveness. Ukrainian universities are actively adopting cloud technologies, but lag behind in the implementation of immersive learning environments compared to international leaders. Immersive technologies have a significant potential for developing students' digital competence when used within active project-based learning. Universities need to make informed decisions when selecting cloud services and immersive tools based on a clear understanding of their needs, capabilities, and constraints. Our research contributes to the theoretical and methodological foundation of design immersive cloud-based educational environment in higher education. However, there are still many open questions and directions for future work, such developing more detailed technical and pedagogical guidelines for implementing this environment in different subject areas and educational levels. Investigating the long-term impact of immersive technologies on student learning outcomes, motivation, and career readiness. Exploring the potential of new technologies such as haptic interfaces, brain-computer interfaces, AI-driven adaptive learning for changing immersive learning experience. Studying the organizational and economic aspects of implementing and scaling up environment in university, including issue of staff development, infrastructure management, business models, and partnerships. We invite research educators and university leaders to engage with these questions and to collaborate on shaping the future of immersive technology and changing higher education. Thank you for your attention, and I will be happy to answer any questions if you have.
Thank you, Tatiana. Questions, please? Alla, please.
Thanks. It was very interesting and informative research. I have a questions. What are the key design principles of an immersive cloud-based educational environment that ensure its effectiveness and adaptability to the need of students and teachers?
Thank you.
Thank you very much, Alla, for your question. Some minutes ago, I and Irina Sergeyevna make our talk at least regarding these principles. It seems be advisable if we give in chat our presentation, where all principles are listed and brightly described. It happens.
Second question.
Nice to see you, Sergey.
Okay.
Nice to see you.
Tatiana, Sergey, next question in text chat from Olga Pinchuk.
I'm sorry, I'm reading. How does the introduction of immersive cloud education environment affect the quality of learning and interaction between participants in the educational process? Thank you, Olga Pavlovna. First of all, we did investigation the direct research on the direct effect on the quality of learning. It was not our goal. But regarding the interaction between the participants, I have at least 5, 10, 20 reasons why immersive environment will be facilitate an interaction. First of all, the immersion is we have not only immersion in some environment. First of all, it's a subject-based related, a classical immersion in some subject. Second is language immersion, which allow us to facilitate our communication facilities. The main task of such immersion to make a continuous for a long time environment which every learning participant can develop your own needful key or subject competences. For example, a classical language environment, a language club where we for some hours talk only in some language. As you can remember from the classical communist story about the family of Ulyanovs, every day of week they communicate in their family in some other language, in English, in French, in German, etc. It's a first part environment. Second aspect of immersive environment is that environment which construct in our idea of new Ukrainian school concept. It's a safe space which facilitate for development the needful competence of our not only primary but more elder students. The space in which they are safe, in which they are alone, in which they are supported. I think it's excellent examples of immersive learning environment, which not IT immersive environment. In the present stage, when COVID-19 distance learning converted into our distance education, we have a virtual learning environment, not only a classical like Moodle, etc., are really a combination of active and passive, combination of real and virtual, as a kind of safe environment which allow us not look at the window and not see the rocket missile. I think that immersion now for our country it's a kind of some hostile from the brutal reality. So we need to make an immersion not in the fantasy or not in dreams, etc. We need immersion in a productive learning and study for our country. Regarding the facilitation of the participants in educational process in a physical environment, for example, language immersion, facilitations is moderated by the organizing of such environment. In a physical immersion like a new Ukrainian school, such interaction therefore facilitated and supported by the teacher and assistant teacher. And at last, in virtual environment, any interaction must be supported, facilitated, and even controlled by the teacher, administration, etc. Environment, the self, immersive environment itself is not communicative supported, but therefore we have an ability to immerse person, not in the collective. Only controlled and management in such environment can facilitate the interaction between participants. And again, regarding the quality of learning, I not say anything about the quality of education, but the quality of learning. Learning is a communication process. Therefore, the NDP of controlled communication, which has a clear aim and goal, is really can affect the quality of learning. Regarding the quality of education is a our national agency. Some can say
and
what
many
about
others.
accreditation.
And many others. One
I'm sorry.
questions and many texts from Sergey, maybe new research on new topic. Okay, this final, because dear participants, please turn on the cameras for a joint photo session, please. I'm sincerely grateful to everyone for taking part in the work of the conference and engaging in research in such difficult times for Ukraine. As part of the workshop today, we are listening to 11 reports devoted to the study of the problem. There were interesting research results, including those devoted to the study of the use of information communication technologies for education issues, which is very relevant. Once again, I congratulate everyone on the end of our workshops. All the best. We will want for everyone in a year. Thank you.